praises us and believing in Jesus' name. Amen.
Amen. Amen. Thank you, Kevin. So today we're going to be talking about Docker. We're going to learn what Docker is, the difference between Docker and virtual machines, the Docker architecture, definition of terms, Docker objects, and then we're going to conclude with a demo. Okay, so what is Docker? Docker is basically an open platform for developing, shipping, and running containers. And running applications. Yeah. So we have a table here that has a difference between virtual machines and containers. I'm going to explain it. Just a minute. So on this side, we have virtual machines, and on this other side, we have containers. Then the second tier, we have infrastructure, which can be cloud, which can be a physical server. And then on the virtual machine side, you can see we have a hypervisor, for example, VirtualBox, VMware. And on this other side, we have operating system instead of a virtual machine. So Docker basically provides the ability to package and run applications in a loosely isolated environment called a container. So as you can see, we have an operating system, and then we have a container engine, and then we have isolated containers. This isolation is the isolation and security allows you to run many containers simultaneously on a given host. Containers, they're basically lightweight and contain everything needed to run the application. So you don't need to rely on what is currently installed on the host operating system. Yeah. For example, from this image, you can see that each virtual machine has its own guest operating system. Yeah, each virtual machine has its own guest operating system. Let's say, for example, this could be Ubuntu, this could be CentOS, this could be Kali Linux, and maybe another one could be running Windows Server. And actually this makes the host machine, it's heavy to run the individual operating systems on one machine. It's quite heavy on the host machine as compared to containers. As you can see in Docker containers, they share the host operating system. Let's say, for example, I could be having an operating system like Windows or let's say Linux. Then I have installed Docker. You can run as many containers. Let's say this container could be running Ubuntu, this container could be running CentOS, this container could be running CentOS. All containers you can run as many containers as you want on one host, as long as you have Docker installed. So basically sharing the host operating system between containers, it makes them very light and helps they boot very quickly and in seconds as compared to virtual machines, which also consume a lot of resources. Yeah. So Docker containers are suited for situations where you want to run multiple applications over a single operating system kernel. But if you have applications or servers that do not need to run on different operating system samples, then virtual machines will be preferred. Yeah, the virtual machine, it does not share the operating system, and there is strong isolation in the host kernel. Hence, it's more secure compared to containers. In a way, containers have a lot of security risks and vulnerabilities, and it is not something that can be overlooked. You need to, as you set up Docker, you also need to factor in things like security. I'm going to be talking about security later. Maybe we can move on to the next slide. which is architecture. As you can see, we have client side. We have the Docker host, which has a Docker daemon. And also we have something called the registry. Don't worry, I'm going to be defining these terms. So basically, Docker uses a client-server architecture, as you can see. The Docker client, it talks to the Docker daemon, this one. The Docker client, it talks to the Docker daemon, which does all the work of running and building containers and distributing all your containers. The Docker client, yeah, and the daemon can run on the same system, or you can also connect Docker client to a remote Docker daemon. So the Docker client and the daemon communicate using a REST API. It communicates through an API. I'm also going to be talking about an API over Unix sockets or a network interface. I'm going to be doing a demo of that, so don't worry about the terminologies I'm using. We also see we have a registry here. I'm going to show you the Docker registry shortly. So some of the terms you've heard me mention include the Docker daemon, Docker client, the Docker registry. Basically, the Docker daemon, which is Docker D, it listens for Docker API requests and manages Docker objects such as images, containers, networks, and volumes. Yeah. We also have the Docker client, which we've talked about, the Docker client here, which is a primary way that many Docker users interact with Docker. When you use commands such as, for example, Docker run, let me go back a bit, Docker run. When you use commands such as Docker run, the client sends these commands to the Docker daemon, which then carries them out. The Docker command uses the Docker API. We're going to be seeing that real time when I'm doing the demo. We also have something called the Docker registry. Basically, a Docker registry, it's like a repository which stores Docker images. As you can see, Docker is a public registry that anyone can use, and Docker is configured to look for images on the Docker Hub by default. You can even run your own private registry, but this mostly it's in a corporate environment where you have to purchase a license for hosting your own registry in an organization. So maybe I can show you the Docker registry. Sorry. Zoom in a bit. So there is something called hub.docker. This basically is a central repository for all Docker images that we are going to be talking about. Maybe I can explore it a bit. We see we have repositories. As you can see, we have different images for different products. For example, we have Oracle, we have MySQL, we have Couch database. We have all these images. We have Ubuntu, we have Postgres, we have Redis. We are going to be using some of these images in the demo. So basically, it's like a repository of an image. If I wanted to get an image of CentOS, I'd search for CentOS. Then I come to the official page for CentOS. Then it gives me a command here that I can use to pull this image to my local machine so that I can start creating containers out of that. Yeah. And as you can see, there are important things like tags included. I'll talk about tags in the demo. Yeah. So basically, this is the Docker registry. It's a central. It's like a central hub for all public images. Yeah. So back to the presentation. When you use the Docker pull or Docker run commands, the required images which we have seen, they are pulled from the configured registry. when you use the Docker push command, your image is pushed to your configured registry. Maybe I can show that. I think I have pushed 2 images. Yeah. As you can see, what basically that means, when you use the Docker push command, your image is pushed to your configured registry. In my own registry, you have to create an account in the Docker Hub page. So once you create an account, it's similar to GitHub where you can upload your project. So these are some of the images that I've managed to upload to the Docker registry. Anytime I want to, or if I want to share these applications with anyone, I can just run this command, or I can just send them a command that they can use. Docker, for example, pull. In this case, it's push. If I had an update, I'd run Docker push to update these image. As you can see, it's a bit old. It's 21 days old. So yeah, I'm going to be showing you how to do this. So something else I've talked about quite a lot is images and containers, but what really is the difference between images and containers? Yeah, so these are basically Docker objects. When you use Docker, you're basically creating and using images, containers, networks, volumes, plugins, and many other objects. This section is a very brief overview of some of those objects. We have image and container. An image is a read-only template with instructions for creating a Docker container. Often, an image is based on another image with some additional customization. You may build an image which is based on Ubuntu image, but installs the Apache web server and your application, as well as the configuration details needed to make your application run. What do you mean by an image is based on another image? Maybe I can show you a demo. As you can see, we have something like MySQL. But as you know, MySQL is basically a database. But as you can see, the tag here, it's written official image. Basically, this is a database which has been built on Linux image. Yeah. And then the author pushed it to the central repository. So if I wanted to run a container specifically for MySQL, I will have to pull. I'll have to run this command in order to pull the image to my local machine, instead of having to create to maybe, let's say, run an image for Ubuntu, then having to install MySQL. This isn't the work. That's basically what is meant by this line here. Often an image is based on another image. Yeah. So when you talk about containers, a container is basically a runnable instance of an image, which you can create. You can start it, you can stop, you can move it, or you can even delete it. We're going to do that in the demo shortly, using the Docker API or the command line interface. You can connect to a container to one or more networks. You can attach storage to it. You can even create a new image based on its current state. Yeah. So for example, you basically need an image in order to create containers. You can have an image, let's say for Ubuntu, then you can create like 5 containers based on the image that you pulled. I'm going to show you, don't worry. So you might create your own images, or you might only use those created by others and published on the registry. You can also build your own image. You can create a Dockerfile, something called a Dockerfile, which basically has a simple syntax for defining the steps needed to create the image and run it. Each instruction in the Dockerfile creates a layer in the image. And when you change the Dockerfile and rebuild the image, only those layers which have changed are rebuilt. So this is part of what makes images so lightweight, small, and fast when compared to other virtualization technologies. Yeah. So By default, a container is relatively well isolated from other containers and its host machine. You can control how isolated a container, network, storage, and other underlying subsystems are from other containers or from the host machine. Yeah. So I think with that, we can proceed to the next section, which is a demo. So I have a lab here. As you can see, it's an Ubuntu machine. I have already installed Docker, and you can see we have its IP here. We'll talk about Docker networks later in the demo. So I'm going to SSH into this machine. Be a bit easier. Awesome. I'm going to stop this here a minute. You can see my screen?
Yeah, yes.
Okay, thank you.
Yes.
So I'm going to take you basically through some basic commands that I feel like you should know for a start, from running the help page, from viewing containers to listing containers, starting, stopping, and restarting the Docker daemon, searching for images, pulling images, running containers, and logs, and deleting and removing containers and images. So I think we can get started. So basically, I'm going to take you through the first command, which is sudo systemctl status docker. This command basically shows you the current status of the Docker daemon, and as you can see, it's up and running and it's active. Yeah. If let's say the Docker daemon was stopped, you could have used start instead of status. And if you also wanted to stop the Docker daemon, you would have used stop here instead of status, right? So I'm going to go to the next command, which is systemctl enable Docker service. Docker service. What does this command actually mean? This command means that anytime you boot your machine, maybe I can run this command once again so that I can explain it better. Anytime you run this command, sudo systemctl enable Docker service, this means that anytime the machine boots up, Docker automatically runs or starts by default. And as you can see, once you check its status, you can see it's enabled here. So if I shut down this virtual machine right now and start it all over again, we're going to find, we're still going to find Docker active and running, yeah? If you wanted to disable it, you would have used the disable switch instead of enable, yeah? Awesome, so let's jump into Docker. I'm going to run Docker, which is going to give us basically a help menu with different options we can run. This is the Docker help page. Let's see. This, we can see we have been given the basic syntax of how we can use Docker on the command line interface. We have Docker, then we have very many options and commands that follow. Yeah, as you can see, there are management commands like network. There are many commands that we can explore. We are going to tackle some of them, which I feel they are really important, like attach, build, commit, list, PS, RMI. So without further ado, let's get started. So the first thing we're going to do is if you wanted to check if you have any images, and we have said images from the Docker registry, like Docker images include things like, I don't know whether you can see my screen. Yeah, this is an example of a Docker image. We're actually going to get this image. I'll show you how to get the image. So if I wanted to check how many images we have on the system, I will have run Docker images. And as you can see, we have 3 images currently on my system. We have one called Oste, my toolkit, and we have another image called Ubuntu, and we have another image called Hello World. I believe everyone should have Hello World if you previously followed my step-by-step instructions, the one that I sent. You can see something called repository. You can see something called tag. You can also see something else called image ID, and the time it was created, and also the size of each containers. Containers are very lightweight. I mean, the images are very lightweight. This one is a bit bigger because I have customized it a bit. I've installed a lot of tools. That's why it's a bit bigger. But as you can see, if you compare an image of, if you compare Ubuntu image, which is around 2 GB, to using an image which is like 72 MBs, it's quite lightweight, and you can see you can run a lot of applications and a lot of containers as well. Yeah. So the other command I like to run is Docker PS, which is going to give us nothing. Why? Because we don't have any containers which are currently running. Yeah. And another similar command to Docker PS is Docker PS-A, which gives you a history of the containers which have been run and some of the commands. This is very important, and some of the commands that were run in each of the containers. Yeah, as you can see, this one was run 4 hours ago. This one was when it was the Hello World was created. This one was exited 7 weeks ago. And as well, something else I'd like you to take note of is the names. I'm going to be talking about names later. I'm also going to be talking about the container ID, which is very important. The image. These are different fields, different categories that I'm going to explain. So if we wanted to know, to get system-wide information about the Docker that we have already installed, you can basically run Docker info, and it will give you lots of information. For example, some of the plugins which have been installed, the total number of containers. If I was running any container, you could have seen running containers. If I had posted some containers, you could have seen some containers. And as you can see, we have stop containers, which are 4, and other many options. Yeah, you can also see the architecture, the host operating system where we have Docker installed. Basically, the Docker info command, it gives you a general overview of the host operating system. Yeah, and settings on the same. So I'm going to clear my screen. We're going to go to the next command, which is Docker network. I think we can do it to help to see what's available. So in networks, we can see basically we have several commands we can append to the network option. We have Docker connect, network connects, we have create. If you wanted to create a network, you can prepend create after network. But for this case, I'd like us to inspect some of the networks that we have already. So we're going to run Docker network ls. As you can see, we have 3 networks, yeah? And the default network is called bridge network. This one, the network ID. This is the network ID for the bridge network. And basically, the bridge network is what I explained earlier. Let's do an if config again. This network is the one we're talking about. This one is the bridge network. And basically, in all, when you install Docker, this is the default network that you're going to use. It's always 172.17.0.1. It's important to note that. Let's say we want to inspect that network specifically. We're going to run Docker network. Let me clear my screen, sorry. Docker network, and then inspect, then specific network, which is bridge. And you can see some of the configurations. As you can see, all containers that are going to be running, they're going to be using this subnet. So if I run 10 containers, they will each be on this subnet, unless you choose to create a different network that is totally isolated from this network you can see here. Yeah. So we are going to move on to the next command, which is Docker search. And maybe I can run a help on it. For this case, let's say we said you're going to look for, let's see. For this case, we said we're going to look for MySQL image, but we don't have it because as I ran earlier, we did Docker images and we saw that we only have 3 images. So maybe we can try search for MySQL image. Docker search MySQL. Just going to wait a bit. Yeah, and we have the results back. As you can see, there's the first option, which has a lot of stars, which tells you this is the official image for MySQL database. And as you can see in the official tag, it's been written as okay. Yeah, and they are. Sorry, is there a question? Okay, sorry. As you can see, there are very many other options. There are very many other images that are running MySQL, MySQL. And if you wanted a specific one, let's say, for example, Elastic MySQL, we can pull it, but we're just going to go with the one that has a lot of reputation, and you're probably thinking it's constantly updated. So I'm going to run Docker. I am going to run my first command, which is Docker pull MySQL. So since I want you to take note of the output that's given here, as you can see, we don't have it currently. So on our system, so what's being done is we are actually pulling it from the Docker registry that I had shown you earlier. This one. Let me show you. this one. We are actually pulling it from here. Just how you, similar to how you would have done in, let's say something like GitHub, where you git clone, then you copy a link. Let's say, for instance, this for this scenario, it's MySQL. So basically, that's how you're going to import the image to your machine. As it imports, maybe it will take quite some time. I can switch to a different tab. And you can proceed from here as it imports. So, as it imports, maybe I can run a different container. If you want to run a container, let me go back again and do Docker images. As you can see, we had an image called Ubuntu. If I wanted to run a container based on this image, yeah, I can run a command such as docker run it. I'm going to be explaining what that means, or I can write it as I-tact, and I'm going to use Ubuntu with a specific tag latest. And I'm going to run this command bin bash because I want. Awesome. So I want you to take note of this two. As you can see, the first one I was running as my machine, as a user called Docker. And after running this container, we now get a shell because we run, this is a command. Yeah, I'm going to explain this syntax. So just a minute. So when we run this this image, we are basically creating a container. Yeah, and as you can see, if we do an ID command, we see we are running the container as a user called root, the root user. Yeah. So I use tag I and tag T. I use two flags, I and T. This basically means I want to run a container and gives that provides me with an interactive shell. Yeah. Basically, that's what I and T means. I like to run it as IT, but you can choose to separate it as I and T. Yeah. So basically, you're running an interactive and attaching the shell to your terminal. Yeah. I don't know if it makes sense. So we can try maybe create a file. Touch test.txt. Then we're going to, I doubt we have them installed. Yeah, test. Let's see. So we're just going to install updates. Oops. Sorry about that. Just going to let it update very fast. Let's see whether MySQL finished. Nice. As the Ubuntu container finishes updating, we can look at what happened here. As you can see, we managed to pull MySQL image, and maybe we can try check if it actually worked. Let's see whether we can have it list. You can see it listed. Docker images. Yeah. Now you can see we have MySQL in our local machine, and it has quite some space, which is 514 MB. yeah, we can do a lot with MySQL. Basically have to start doing configurations, but for this example, I'm going to be using Ubuntu. Let's see whether I finished updating. Okay, it's still updating, but maybe something we can check. I told you about a command docker ps. Since we have already started, since we already started a container which is currently running, when you do docker ps, you can see that yes, we have a container which is running. Before we didn't have some output here. You can see we are running a container. Yes, this is a container ID based on an image called Ubuntu, and this is a command that I executed as I created a container 3 minutes ago. And currently, as you can see, the status, it's up and running for the past 3 minutes. We have not attached any ports to it. Let's say if I had an application in the Ubuntu image and I wanted to expose it to the external network, I would have mapped the container to a specific, let's say, an internal port like 8080 to an external port 8080, whereby I can now access the container on my browser. Let's say if I had something like WordPress running on a container, I will have used ports, but for this case, since it's a test container, I didn't attach any. Something else I want you to notice the names. The names given. As you can see, the name given to this container is Amazing Lewin. Yeah. So as we proceed with the demo, I'm going to show you how to run a container by assigning your own name. But if you run a container the way I had run this Ubuntu container without assigning any name, Docker basically gives you random names. Maybe I can show you others. Let's see. Docker generates random names for your containers. For example, you can see there's one called Amazing Lewin. There's another one called Flamboyant Joliot. All that, but we can have a container with a specific name. Yeah. So I don't know whether it finished updating. Yeah, it finished updating. Maybe I can try write to that file test. Oops. Oh, I didn't install. Install theme. Happens very fast. Yes. Maybe as it finishes installing Vim, I think it's actually almost done, but let's go to the other tab. I've talked about assigning names to your Docker containers. Yeah, maybe we can try run a different another second container. Let's say Docker run. I want to run a container and get an interactive shell. Then I'm going to name this container. Let's say our first app. Then I want to run this container based on an image called Ubuntu with the tag latest. And also want a bin bash shell. Yeah. Let's see. ID. You can see we are now inside the container. I want you to, after you run the Docker, if you run IT, with a bin bash, you expect to get a shell, but there's a way you can run Docker, you can run a container in the background. I'm going to be showing you how to do that. For this case, I'm just going to, let me config. I want you to, oops, I don't have NetTools installed. Install. Sure. Okay, let's try. Try exit. If we do Docker ps, sorry, Docker ps, we can see that we're still having the first container that's updated, that's installed, that's currently installing Vim. It's still up and running, but I started the second container and you can see it this time round. This is because I terminated that container. Yeah, but if you wanted to see that container and the command that I previously ran, we can see it in the first column where we have it's Docker container ID. We can see we ran that container based on Ubuntu image, and this is the command that we run. And I created it about a minute ago, and the current status is exited. Yeah, but the other container is still running. And as you can see this time round, since we assigned a name to our container, it's now being displayed here. Yeah, so if you choose to run a container without assigning it a name, sorry, yeah, we have someone raise their hands. Kevin, you can go ahead.
Yeah,
sorry?
Net-tools to
oh,
install.
yes. Oh, thank you for that. I'm going to do that again. Don't worry. Thank you. So as you can see, yeah, our container now has an assigned name, which will be easier to, let's say if you're working on an application, let's say if I had an image on Ubuntu and I wanted to deploy some, let's say something like a sim tool, and I want to create I want to set up different kinds of the sim tools. We can have something like alien vault running on one container based on Ubuntu image. We can have another one for elk running on another on a separate container, still on the same image, and so on and so forth. You can basically run a lot of containers at a go. Yeah. I don't know whether there's something I wanted to demonstrate. Let me see whether it finished. Yeah. This stuff. Yeah. I think it should be done by now. Yeah, we have the test file. So let's try Vim. Yeah, you can see this is a test file. Then we're going to exit. We're going to save it. Maybe you can try cut it to confirm that it's actually there. Yeah. So we have created a file. So let's say we created a container and saved some output, but after, the moment you run the exit command, you basically exit or maybe terminate the container, but you can later start it, or you can choose to remove it completely. Yeah. So Kevin said you talked about, let's say, apt install. I want to also demonstrate something else on the networks. Apt install NetTools. I think it's that way. Yeah, that way. Maybe I can start the other container. I wanted to show you how these containers communicate with each other. Let's see. I'm going to run another container with the name our second app. Second application. Nice. You can see we're still running as root, and we're going to go ahead and install NetTools. NetTools. Oh, I need to update the machine first. It's going to be taking quite some time. But you can go to the other container and yeah, you can see, maybe you can check the IP address. Yeah, you can see this container has an IP address of .2. Yeah. And let the other one finish. So that it can make sense. It's going to take quite some time. So if we run Docker PS tag A, we can see, yes, we have another container with the name, our second app. So you can create as many containers as you probably wish. So I wanted to demonstrate something here on the networks. If config, this is on my main machine. You can see I talked about this subnet, which is my main machine has an IP of .1. And in this container, we saw that we had it had an IP of .2. So I want us to test this other container. What? We have to install it. So it's going to be a bit faster. Awesome. Config. You can see the second container has an IP address of .3. We can try see whether from the other container we can communicate to this container. I don't know whether it's going to accept this. Yeah, the ping command was not found. Just a minute. Oh yeah. Oh yeah. So yeah, I think it's done by now. Yeah, you can see from the first container with the IP address of 2, we can ping another container. So there is that intercommunication. I'm just going to stop this. Yeah, there is that intercommunication between the different containers. So you can be having, if you wanted to let's say, let's take this kind of a scenario. You have one container running WordPress, yeah, and you have a second container running an instance of a database, let's say MySQL database. So when you are creating or you're designing an image for that product, yeah, you can, there's a way you can network the two containers using networks. That's a bit complex for now. I can talk about it in the next section. The next session we'll be having, I'll show you how to do that, to create our own containers. I think that's beyond our scope for today. And also from this other machine, this has this container has an IP address of .3. We're going to try ping the other container, and as you can see, is that communication. Yeah, awesome. So if I wanted to exit this container, but still run this container in the background, yeah, there's a way you can do that. In the first command, in the first container, I basically exited and that terminated that container. But if I want to have this container to continue running in the background, I can simply hold my control and press P followed by Q. And that basically backgrounds that container. And as you can see, I'm back on my main machine. Yeah. Maybe I can try check the state of that exited container. Docker PS. You can see they're both running. Yeah. Docker, maybe Docker PSA. Yeah. Docker PSA. They are both running. One is running in the background, and the other one is we still have a shell to the second container. Yeah. So let's see. We stopped. We exited the first container. What if we wanted to come at a later time and start that container again? Yeah. So we're going to do something like let's see. I'm going to run Docker PSA again, and I want to run this container, our first app, which we exited 11 minutes ago. Basically, what I'm going to do Docker start it, and then I'm going to append it, its container ID. Yeah, I believe it's this one, Docker start. Awesome. You can see I managed to start that container again. But in order to get a shell, I need to run another command called attach. Docker attach, and then I'm going to use Docker. I mean the container ID. You can choose to use the container ID, or you can also use the name that we created. In this case, we can, instead of using the Docker, I mean the container ID, I'm going to be using the name we added, which is Docker attach, our first app. And you can see we have our shell back. I don't know, let's see whether, yeah, you can see we have a shell back as a root user. Yeah, I hope that you have understood. Yeah, you have understood that. So I'm going to background this container. I'm just going to hold Control again, Control P, followed by Control Q. That backgrounds the container. So let's say I wanted to rename this container. Instead of calling it, let's pick another container. Let's say I wanted to, let's check the current status actually. Containers. We see we have all containers, the 3 containers running. This one is still running in the background. This one is still have a shell, and this one is still running in the background. So let's see whether we can try change a name of an already existing. or maybe I can use an existing one. Let's say like peaceful cray. What was it running? It was running. Yeah, let's try change this one, peaceful cray. So we can basically do Docker rename. Then we're going to add the old name and we're going to give it a new name. Let's say new name. Hopefully that works. Yeah. If we do Docker PS stack A, sorry, I typed that wrongly. It's supposed to be Docker. Let me just clear my screen. No, Docker PS stack A. You can see now we have managed to change a stopped container. It used to be called, maybe I can scroll up a bit. It used to be called Peaceful Cray, but we have managed to rename it to something like new name. That's how you will rename containers. Yeah. Say we wanted to remove the history. This is the history I'm talking about. When you run Docker PS with attack A, this is basically the history we are talking about. Let's say I run an old container like Hello World and I don't need it anymore because of maybe accumulating space over time. What I can run is Docker RM, just like a similar command in Linux, Docker RM. Then you can choose to use the container name, which is, let's say this one was called Buffy, whatever. We can choose to, we have managed to remove that. Maybe we can try remove another one. But this time round, we are not going to use the name. We're going to use the container ID, which is Docker RM, the container ID. Maybe we can try check the history again to see whether they're still there. It shouldn't be there. Yeah, as you can see, we have managed to remove the history, the Hello World from the history. That's how you'll go about it. Like that's how you'll go about removing containers. You can choose to use the container ID or the names. Yeah. Hi. Let's say we have a container like we already have a container running called Amazing Lewin, and we want to inspect. Let's say in this case, let's assume Anthony created a container. Kevin created a container. Grace also created a container. And I wanted to inspect. I wanted to know some properties about the container. So what I would have done, let's see, let me clear my screen. It looks a bit cluttered. Let me start again. Awesome. So if I wanted to inspect a specific container, I would have run Docker inspect and the container name or the container ID. I like using the container ID because it's a bit easier. Maybe you can try and inspect this container called our second app. And we get a summary of details pertaining the container. And you can see there's a lot of settings. So you can see there's a bean bash shell, the current status it's running. We wanted to, there's a lot of information you can get to know about the container. Yeah? Very many options, DNS, links. That's a bit complex now. I can talk about it in the next section, in the next session, because of interest of time. And as you can see, we have volumes. You can attach volumes to this container. You can see the image that you're currently using. Currently, we don't have any volumes attached to this container. We don't also have any ports mapped to this container. You can see we're also using a bridged network. Yeah, and you can see the IP address of this container, the MAC address of this container, a lot of information basically. Yeah. Or another way, we ran Docker inspect, or you can also choose to run Docker container inspect. Then, sorry, I copied that. Should not have copied that. What is the container? Let me pick a different one. Yeah, that one. Docker container inspect. It's one and the same thing. If you choose to run Docker container inspect, then or Docker inspect, then the container ID, it's one and the same thing. Yeah. Good. Sorry. So I think we're going to go to. I think I'm almost done. So I'm going to run the last 4 commands. Then we can call it a session. Yeah. So let's say we have an image. We said to list images, we are running Docker images, and we have 4 images. And I don't want to have my SQL image because it's consuming quite some space. So if I wanted to remove this image, I will probably run Docker RMI. Note, we have used this time round RMI instead of RM. When you use Docker RM, you're removing the container history. That's a container. But if you talk about Docker RMI, we're basically removing the image. We can say I stands for image. That's a bit easier for you to remember. So Docker RMI, then the image, we can give it, we can use its image ID. I think that should work. Just give it a moment. And as you can see, we have managed to delete it. Maybe you can try confirm Docker images. And this time around, we can see that we don't have it anymore. We have deleted it. Yeah, that's how you remove an image. But then, if we try removing the Ubuntu image, we can get an error. Or rather, if we try running, let me demonstrate. I don't want to remove Ubuntu. Let me demonstrate it with the hello world. So I'm just going to run a new container Docker run. I want an interactive shell. I also want to name this container Steve, and I want to run the container hello world, which has the tag latest. You know, the reason I'm using the tag after the image name is because I can be having Ubuntu and I can be having very many different versions of Ubuntu. As you saw in the Docker registry, maybe let me talk about that a bit. Share my screen. Yeah. Do something like Ubuntu. As you can see, we have different flavors of Ubuntu. Let's say I had Ubuntu, then I had Ubuntu, let's say like the Xenial version, the Xenial edition. If I also had Ubuntu rolling would have been here on the tag column. But in this case, we have the official image, which always has the tag latest because it's maybe constantly updated. So let's say if I had like 10 variants of Ubuntu, you have to specify which Ubuntu to use. Otherwise, it will default to Ubuntu latest. Yeah. So in this case, I'm running a container and giving it, I want an interactive shell. I'm naming this container Steve, and I'm running I'm running this container out of an image called hello world with the tag latest. Let's say if I had many images for hello world. Then I also want an interactive shell. So bin bash. Oops. Okay, let me see. Oh, the container name Steve is already in use by container. Oh, you have to, okay. Yes, this is the error I was talking about. Let's say I wanted to remove this image, but the container is currently, the container is running. Yeah, so if I wanted to remove this image and you can see that it's currently running, you get this kind of an error. So how will you go about this? You'll do Docker. You have to stop that image first, and you can see that you've been given its ID. I don't know whether it's going to work. Let's try that. Yes, we have managed to stop that container. And then we are going to, after stopping that container that was running, we are going to remove that container before we remove the image. So Docker container RM, since it's a container, then the image ID, yes, that's the image ID, yes. Yes, we have managed to remove that container that was running. And now we can proceed to remove the Docker image, which has an image ID of this is the image ID. Let's see whether it's going to work. It's an name. Oh, we must use the first mode. Let's see. It's the first. Yes, we have managed to remove that image. Maybe we can try counter check to confirm that the image actually has been removed. Awesome. So as you can see, we have 2 containers left. We had 4 containers in the beginning. We had MySQL and Hello World. So we have managed to delete MySQL and the Hello World image. So that's how you'll go about removing an image, which maybe I can go through that again. If you wanted to remove an image and a container is running, it's quite impossible. You get this kind of an error. So you first have to stop that container. Then you have to remove that container. Then you need to remove the image. Yeah, that's basically how you go about that. So the last thing, yeah, once again, Docker images. Let's say I have an image like the first one, though it's quite big. I'm going to use the second one. Let's say I have an image that I have customized, like the second one, Ubuntu, which is the latest version, and I want to export it in a compressed format, like a tar file. Yeah, like a zipped file. I want to share this file amongst my members at the office. I want to share it with Kevin. What I can do, I can save it into a tar file. You can do something like Docker save. You append the tag O, which is for output. Then I can call it for Kevin. Let's see, for Kevin.tar. Then I want to export this specific container called Ubuntu latest. Yeah, Ubuntu latest. Let's wait for it. Show you the difference. Yeah, ls minus la. As you can see, we have the tar file. We have already created that tar file. So we can just copy this file to Kevin, and assuming that we've sent Kevin this file, how will Kevin load this file to the Docker? That brings us to our next command, which is Docker load. Then I, maybe you can see what I means. quick one, help. You can see I is for input string. We want to specify which tar file do you want to load. Yeah. So for this case, it's Docker load tar file called for Kevin. Basically, we have imported. It's like how will you? It's like it's similar to how in a virtual environment you can import like a Kali Linux VM into your. You can download a pre-configured virtual machine for Kali Linux and just import it to your virtual machine, either VirtualBox or VMware. So similarly, that's how I have done for the Ubuntu image. Maybe I can try see whether we have two instances of the same container. Docker images. Yeah. Okay, it can't display two of them because it has the same name, but basically that's how you load the tar file. Yeah. And I think with that, I showed you how to rename containers, but I didn't show you how to rename the Docker images. So assuming I want to rename my first image. Yeah. So what I can do, it's similar to the containers. I'll run Docker tag. And this one was called my toolkit. Then I'm going to append the tag name, which is version 1 and space. Then I'm going to call it again. Let's say, sorry, I can call it Ubuntu my toolkit any day. And this time round, I want to create, I want to rename it as maybe version 2. Then you enter. When you check Docker images again, we can see now we have 2 versions of the same. Awesome, right? We have version 1 and you also have version 2. Then you can keep working on the same. If I wanted to delete, once again, if I wanted to delete the image, I'll do Docker RMI. Then I can use this container ID. And for this case, I can't do that because they have the same container ID. So it's basically identical. It's like a duplicating. Yeah, it's like having a replica of the same image. So I can't go ahead and delete it because it will delete the first one. It will overwrite the first one and both will be gone. So that brings me to the end of this session. I hope you learned something and thank you for your time. Do you have any questions? Hello, do you have any? Okay, sure, go ahead. Go ahead.
Yeah, thank you very much for taking us through. It has been very educative. Yeah, I think very expensive also. But what I wanted to ask is about the logs. Let's say if you wanted a log of what you have been doing, like the renaming and things.